Welcome viewers. We welcome you to the next class of column. We will discuss about a numerical question which is important in semester point of view or any other competitive examination. So let's move. We will consider this as number 1. So in previous classes we have seen the limitation of Euler's formula and we have the legendary crippling load formula. Okay, so we will use it so we can evaluate the necessary data. So let's think a column of building looks not safe. CEO of a company hired civil engineer to check whether the column is safe or not. Okay, that is the concern. Column is of mild steel. Mind it, if we recall the table, we will have the mild steel, cast iron, and two other metal. Okay, so the corresponding values we have to remember. We will show you the values actually, whose length is 3 meter. The column is of length 3 meters and both ends are fixed. These are the end condition. As we discussed earlier, load coming on the column is 400 Newton. Okay, so because of this 400 Newton force, is the column safe or not? It is asking. Critical stress on the column is 320 to 10 to the power 2 Newton per meter square. There is a unit mismatch, that is it is in meter and it is given in centimeter. So we have to uniform this unit actually. Cross section of the column is circular with 24 centimeter outer diameter and 20 centimeter inner diameter, 24 outer diameter and 20 inner diameter. So we will have only 4 centimeter solid material. Now check whether column is safe or not. It is made of which metal? Which material? Actually mild steel. Okay. Now let's us jot down the given value. That is, in order to make solution of such problem, we jot down the given value. That is, first of all, outer diameter, which is denoted by capital D, that is 24 centimeter. Inner diameter, that is denoted by letter D, that is 20 centimeter. Okay, length is 3 meter. Given is length of the column is 3 meter. So in centimeter we need the value. So 3 into 100, that is 300 centimeter length of the column. Critical stress, that is sigma C is equal to 320 into 10 to the power 6 square centimeter. Okay, and the column is made of mild steel. Then the Rankine constant. Is given by L is equal to 1 divided by 7,500. Okay. Then in order to find out if the column is safe or not, we need to know the critical or crushing load. Okay. Sorry, crippling or crushing load. That is the value of sigma CR. What is the value of sigma CR? Okay. Now let us move to the solution part. That is, we know from the previous class, effective length of the column is given by effective length of the column, that is LE, defined by LE is equal to L divided by 2. Here L is 300 centimeter. Okay, so 300 divided by 2, that is 150 centimeter is the effective length. Okay, cross sectional area of circular Okay, cross section we have to find out. Then we have to find out the cross sectional area. Cross sectional area of the circular column A is pi by 4 into pi by 4 into d square minus outer diameter square minus inner diameter square. Okay, from here if we put the values, we will have the value 138.23 centimeter square. Okay, now we need next radius of gyration. Now we need radius of gyration. Radius of gyration, which is denoted by r, and it is evaluated by formula moment of inertia divided by cross sectional area within root. So if we put the value for circular external moment of inertia is 84, you can calculate it by using formulas. 8432035 divided by 138.23. We have this area. So from here, if we calculate it, it will give us the value of radius of gyration as 7.81 centimeter. Okay. Now, crushing load we have to find out. In order to find out the crushing load, we have to use the Rankine formula. Now, crushing load. Now, crushing load. Using Rankine formula, which is given by P is equal to sigma C into A divided by 1 plus A LE divided by R whole square. This is the Rankine formula, right? If we put the values here, then we will have the value of P. So what will be that? From here, let us see the value of mild steel, that is 320. Okay, 320. FC value is 320. So from here, 32 into 138.23 divided by 1 plus 1 divided by 7500 into 150 divided by 7.81 whole square. If we interpolate this calculation, we will have the value of crushing load is equal to 4216 Newton. Okay. Now, as we know, so let me erase the given value. So this can be right in here. So as we know, there is a certain relationship between factor of safety, crippling load, and safe load. Okay, from that equation, we will find out the safe load. Crippling load, the relation is like crippling load is equal to safe load is equal to safe load into factor of safety, that is FOS. So from here we will have the value of safe load, that is PS is equal to crippling load. What we will have, that is 4216, and what will be the factor of safety? We consider it in between 2 to 5 for cast. For mild steel, here we will take the factor of safety as 5. Then we will have the value of safe load, which is 843 Newton, and it is much higher than the value given or asking in the question. So in this context, we can conclude and can say your CEO of the company, that is column, is absolutely safe because it can take twice of the load which is actually present in the system. Okay, so you can conclude it column is safe. So you can conclude it column is safe. So column is safe. So this is the end of the first numerical question. It is very interesting question actually. So in this manner, we will design a column in the next class. So see you in the next class. Thank you so much.